Have you ever felt like you're just like, I don't know, drowning in AI news?
Oh, absolutely. Like
Yeah,
trying to drink from a fire hose.
exactly.
Yeah.
It feels like every single day there's some new breakthrough or a new term or someone claiming everything's about to change.
Hmm.
How do you even keep up?
Yeah.
And more importantly, like what actually matters in all that noise?
It's tough.
Well, that's pretty much our mission for this deep dive. We want to cut through all the hype, you know,
Yeah, get to the real substance.
and show you what the actual cutting edge of AI looks like. We'll touch on the big abstract stuff, think quantum computing meets general AI,
Whoa, yeah, big concepts.
but also get really concrete. It's looking at what giants like Google are actually building and rolling out now.
And for that, we've got some great sources lined up. We're drawing from Nicholas Babin's analysis on AI's future. It gives a really broad, visionary look.
Okay.
And then we've drilled down into specific reports about Google's work from ABC boot camps and CNBC.
So a mix of the big picture and the specific examples.
Exactly. The idea is to uncover some maybe surprising facts and help you, the listener, really grasp where AI is going and who's building the roads to get there.
Right. So to really get a handle on this future, we probably need that high-level view first, right? Like a map.
Definitely. And that first source offers just that, like a 10-point compass showing the key directions AI is heading in, where this really mighty force is going.
Okay. Lay it on us. Where does it start?
Well, it starts by contrasting where AI is now versus its, frankly, staggering potential. Point one is quantum computing and AI.
Okay. Quantum always sounds like sci-fi.
It kind of does, but the core idea is simple enough. Normal computers use bits, zeros, and ones.
Right.
Quantum computers use qubits. And because of quantum weirdness, they can be 0, 1, or both at the same time.
Okay. Still sounds a bit sci-fi, but go on.
Huh, yeah. But pair that with AI, it means they can process just vast amounts of complex information simultaneously. It's not just faster, it's different.
Yeah.
Exponentially so.
And that unlocks things like,
Things like revolutionizing drug discovery, simulating molecules in ways we just can't now, or building incredibly complex climate models, things that are currently impossible.
okay, so quantum changes how AI thinks. What about what it can think? That brings us to general AI, right? The sort of holy grail.
That's exactly it. That's point two. And there's a huge difference between what we mostly have now, narrow AI.
Like my voice assistant or, facial recognition.
Precisely. Those are tools designed for one specific job. But general AI, or strong AI, that's the dream of a machine that can perform any intellectual task a human can.
Any tasks.
Yeah. Integrating learning across totally different areas, showing real cognitive flexibility. We see glimmers with things like transfer learning, but true general AI is a massive leap we haven't made yet.
It feels like with that kind of power, the human side becomes even more critical. How do we manage it?
Which leads perfectly to the next points. AI ethics and regulations.
The rules of the road.
Kind of. Right now, we're mostly reactive, right? A new AI pops up and we scramble to figure out the rules.
Yeah, seems like it.
The future vision is more proactive. Imagine international bodies setting actual global standards before things get out of hand, ensuring AI helps us, avoids misuse, built-in safeguards.
That makes sense. And that would enable better collaboration.
Exactly. Which is the next point. Human-AI collaboration. Forget the simple interactions we have now. Think augmented intelligence.
Augmented intelligence like what?
Like a doctor working with an AI during surgery, getting real-time insights, or an artist co-creating music with an AI partner. It's about synergy.
Not replacement, but working together.
Precise.
Okay, that's fascinating. What about some of the more out there applications beyond screens?
Right. So next up, neural interfaces and brain-computer interaction.
Oh, okay. Like plugging your brain in.
Essentially, yeah. Moving beyond keyboards and touchscreens to interfaces where you could communicate with or control AI just by thinking.
That is serious sci-fi territory.
It feels like it.
Yeah.
And then there's AI-driven creativity. AI already helps make graphics or music, sure. But the future might see AI actually co-authoring a novel or co-composing a symphony. Where does the human creativity end and the AI begin?
That really blurs the lines. But can AI truly understand something like emotion? Or is it just faking it?
Great question. That's emotional intelligence in AI. Today's AI, it recognizes patterns in data that correlate with human emotions.
So it's easier typing angry words, maybe?
Sort of, yeah. But it doesn't feel anger or understand it. The future goal is AI that can genuinely recognize, interpret, maybe even emulate human emotions more deeply.
What would that even be used for?
Imagine truly empathetic customer service bots. Or teaching tools that adapt to a student's frustration or excitement, maybe even companionship robots for the elderly that offer genuine comfort.
Wow, okay. That has huge implications.
It really does. And it's
Yeah.
not just about individual interactions. AI is set to change whole systems. Think about decentralized AI.
Decentralized, like
Yeah.
not owned by one big company.
Exactly. Right now, the most powerful AI lives on huge centralized servers owned by, the big tech players.
Hmm.
But imagine AI models running across distributed networks, maybe using blockchain. That could democratize access, reduce that monopolistic control.
Spread the power out a bit.
Potentially, yeah.
Right.
And think about AI in environment and conservation. We use it for modeling now, but imagine AI actively helping.
Yeah.
AI-powered drones planting trees efficiently across vast areas. Or AI systems optimizing clean energy grids second by second, balancing supply and demand perfectly. Real-time, active contributions.
That's a much more active role.
Definitely. And finally, wrapping up this 10-point vision, the idea of AI learning how to learn.
Meta learning.
You got it. Lifelong learning machines. Most AI today starts from scratch when learning a new thing.
Right. You have to train it specifically.
But future machines might transfer knowledge. Like how you use what you learned in math to tackle a physics problem. They could adapt foundational knowledge to new, different challenges.
Making them way more versatile and efficient.
Exactly. Continuous evolution without constant, massive retraining.
Okay, that whole 10-point vision is a lot. It's huge. Expansive, maybe a little intimidating.
It is. It's a massive landscape.
So how does a company like Google fit in?
Yeah.
Are they actually building this future now, or is it still mostly theory for them?
Oh, they are absolutely building it. You can see it in the tools they're releasing. They're making things possible that really did seem impossible just a short while ago. Real-world tools, not just lab experiments.
Okay, let's get specific then. What are some of these top Google AI projects that are making waves?
Well, the big one you hear about is Gemini, and now Gemini 2.0.
Right, Gemini. More than just a chatbot, I hear.
Much more. It's what they call multimodal. It understands and works with text, yeah, but also pictures, videos, sounds, even computer code.
All at once?
Pretty much. Gemini 1.0 came out late 2023. Then Gemini 2.0 landed late 2024. And this newer version, it doesn't just understand stuff, it can create images and sounds too.
Wow.
Plus, it's apparently much smarter at reasoning, and it's being integrated deeply as an assistant in Google Search and Maps through something called Project Astra.
Okay, so Gemini's the big, powerful one. Anything else?
Yeah, they also released Gemma early in 2024. That one's different. It's a family of lightweight, open source models.
Open source, so developers can use it.
Exactly. It's like giving builders the bricks and mortar to create their own AI applications, fostering innovation beyond Google's walls.
Yeah, it makes sense. So those are practical tools, assistants.
Mm-hmm.
What about AI changing fundamental science?
Yeah.
Pushing knowledge itself?
Absolutely crucial area. And that's where AlphaFold 3 comes in. It's from DeepMind, which is part of Google.
AlphaFold.
Yeah.
That's the protein folding thing, right?
It's very same. It predicts the 3D shapes of proteins with incredible accuracy and speed.
And why is that so important?
Because a protein's shape determines its function. Understanding that is key to understanding diseases and designing new drugs. AlphaFold basically took a process that could take years in a lab and crunched it down to hours or days.
That's huge.
It's Nobel Prize huge. The creators actually won the 2024 Nobel in chemistry for it.
Wow, okay. So that's a massive scientific impact.
Definitely. And they're also big in connectomics, using DeepMind and TensorFlow to help map neural networks in the brain, analyzing huge amounts of brain data.
Understanding our own intelligence to build artificial intelligence.
Kind of poetic, isn't it? And there's also Neural GCM, that's their generative contextual model. The goal there is to make generative AI, like Gemini, much better at understanding context, nuance, not just spitting out text.
Right, getting beyond just surface level understanding.
Exactly.
Okay, this is all fascinating, but you mentioned quantum computing earlier. How does that connect with Google's AI work? That feels like the ultimate frontier.
It really does, and Google is making a massive bet here with their quantum hardware, specifically the Willow chip.
Well,
Julian Kelly, who leads the quantum hardware team at Google, put it really well. He said quantum and AI could really complement each other back and forth.
the energy again.
Totally. Willow was unveiled late last year, and it hit a major milestone. It solved this specific benchmark problem way, way faster than any classical supercomputer could imagine.
Faster is good, but quantum's always had an error problem, right?
Yeah, it has, but that was the other breakthrough with Willow. They managed to reduce the error rates exponentially. That got people really excited. John Preskill, a top quantum physicist, called it a milestone for the field.
So why is quantum so vital for AI now? Is it just about processing speed for these huge models?
Speed is part of it, but there's something maybe more fundamental happening. AI models, especially the biggest ones, are apparently hitting a data wall.
A data wall, like they've run out of internet to learn from?
Kind of. They've absorbed so much of the high-quality text and data available online. Getting more good data to keep improving is becoming a real bottleneck.
Oh, I hadn't thought about that.
And that's where quantum could be revolutionary. One of its potential killer apps isn't just processing data, but generating completely new, novel data.
Generating data, how?
Julian Kelly used AlphaFold as an example. It learns from data based on quantum mechanics, but that kind of data is actually really rare.
Ah, I see.
A quantum computer, because it operates on quantum principles itself, could potentially generate vast amounts of this physics-informed data that classical computers just can't create authentically.
Feeding the AI beast with quantum-generated food.
Exactly. It could unlock new levels of performance for AI in science, materials, medicine. And Kelly thinks Google is maybe only 5 years away from a practical quantum application, something useful that only a quantum computer can solve.
5 years. That's really soon in the grand scheme of things.
It feels incredibly close for something so revolutionary.
Okay, pulling this all together, these advancements are just breathtaking. But it brings us back to the human element, doesn't it? What does this all mean for us?
It absolutely does. And that first source we talked about really nailed the conclusion. This future isn't just about algorithms and chips. It's about intentionally crafting a symbiotic relationship between humans and AI.
Symbiotic, meaning mutually beneficial.
Right. Guided by innovation, sure, but also by strong ethics, by wisdom, by foresight, which, interestingly, ties right back to Google's public stance on safety and ethics first. They talk a lot about giving users control over their data with AI.
It's one thing to say it, another to implement it perfectly, especially when the tech moves so fast.
True. And that really highlights the core challenge, doesn't it? Taking these incredible scientific leaps, these mind-bending possibilities,
Yeah.
and translating them into real-world benefits that actually help people, broadly speaking. It's not automatic.
No, definitely not. It feels like a huge responsibility.
It is. This path AI is on, it's just loaded with potential, both amazing and, frankly, a bit scary. We need that balanced optimism about what we can achieve, but real pragmatism about the risks and the work needed.
Work to make sure it genuinely benefits humanity as a whole.
Exactly. To ensure these tools help us redefine what it means to be human in a good way in this world that's becoming more and more driven by machines.
Wow. We've covered a lot. From those 10 big ideas about AI's future, quantum, general AI, ethics, all the way to Google's concrete projects like Gemini and AlphaFold, and that crucial link with the Willow quantum chip,
It's huge spectrum.
and that connection between AI needing new kinds of data and quantum computing potentially creating it, that feels really profound, like a key unlocking the next stage.
It could very well be. It highlights how interconnected these frontiers are.
So to leave our listeners with something to chew on,
Yeah.
given everything we've discussed, especially that idea of lifelong learning machines, AI that keeps evolving, what new responsibilities fall on us, on humans, as AI develops these capabilities? How do we actively guide it, make sure it stays aligned with the values we actually want it to reflect?
That is the question, isn't it? How do we steer the ship?